Hello everyone. Today we are going to study about the second application of Fajan's rule, that is stability of ionic compound. So we can classify anion as two types. One is monoatomic, that means which contains only one atom, and second one is a polyatomic, that is more than one atom. For example, H minus, F minus, it is monoatomic. For polyatomic, it is carbonate, OH minus, SO4 2 minus. So in case of monoatomic anion, the stability is directly proportional to polarization. But in polyatomic, the stability is inversely proportional to polarization. So how to understand this? So in case of monoatomic anion, consider an example of NaCl. So we can write it as Na plus and Cl minus. So here Na plus will polarize the Cl minus, that is Cl minus is a monoatomic, and this will polarize us and it will form a stable compound called NaCl. So here decomposition of NaCl won't take place because polarization is more, means it will hold strongly Cl minus, so it forms a stable compound. So in case of polyatomic, consider lithium carbonate. That is 2 Li plus CO3 2 minus. So here lithium positive will polarize us the anion, that is anion is here oxygen. So here cation, it polarizes this negative charge towards itself and it will form lithium oxide plus carbon dioxide. So here we can observe that the decomposition of lithium carbonate takes place. That means decomposition is what? The compound is unstable. So that's why here in case of polyatomic, if the polarization is more, that means decomposition occurs, that means the compound is unstable. Like this you can understand in this way. Like suppose there is a boy and here is a girl. So the boy will attract girl towards himself. So they will form a new relationship bond. So here also there is a boy, but this time the girl is with his father. That is like polyatomic. So obviously boy will attract the girl and they will form a new relationship. But in this process, father is separated. So separated means decomposed. So this is not a feasible condition to have a healthy relationship, right? So yes, this is in case of polyatomic. So now let's solve some questions. So we can see that here the anion is monoatomic, that is nitrogen 3 minus. So that means polarization is directly proportional to stability. So we can see that lithium has smaller size, that means this is the polarization order, hence the stability order. So that is the reason only lithium nitride exists and these compounds not even exist also. Here the anion is polyatomic. That means polarization more means stability will be less. So order of the stability, or we can say thermal stability, will be this. So in this case the anion is H minus, that is a monoatomic. That means polarization is directly proportional to ionic stability of ionic compound. So here the anion part is nitrogen, that is monoatomic. So don't think that it is a polyatomic. So it's just a valency balance. So it is a monoatomic, that is N3 minus. So in monoatomic, that means beryllium is small size, that is more polarization. So this is the order of thermal stability. So we know that OH is a polyatomic, so that means this is the order of stability. So like this is all about the thermal stability of an ionic compound.